So this time is going to be my video for the Capstone final, the final project overview, a little bit about my my SDLC that I made, my hybrid SDLC, and what we were required to do for the final. Guess I'll start with my SDLC. Didn't realize I didn't have it up here. Let's see. So for my SDLC comparison, we were supposed to compare the, not really compare, use the advantages and get rid of the disadvantages of the spiral model, the waterfall model, the agile model, object-oriented analysis and design model, and apparently we were supposed to do rapid prototype. I unfortunately mistook it. Guess I kind of confused myself when I looked online. I searched for the rapid prototyping, and one of the things that came up was RAD, and I confused myself. So I ended up using RAD. Didn't realize it till I was done with my paper, and I was looking back through the requirements, and I had already sent my paper to you. Take the points off for that. It's all right. But I still did a good job. I still used it the same way. Just one model was wrong, I guess. So it is what it is. So we're supposed to use the advantages. So what I did, I actually kind of started off. I actually used the paper that I did for, what was that, project 2, the comparison of the spiral model and waterfall model. I actually used that paper. It was already formatted, had a lot of information in there about 2 models anyways, so why not, right? Save me some time, save me some writing. 6 pages is a lot. So yeah, so I started off with sort of an overview of each model, a little bit of history about them, their phases and stuff. Spiral model has 4 different phases: the identification stage, design stage, construction stage, and the evaluation and risk analysis stage. Waterfall model, well, spiral model, as we all know, goes through spirals. It can be never ending. Just goes around and around until you are completed. Whereas then the waterfall model is a linear sequential model, meaning it's in a line and it's sequential. Can't do one step till you do the next. I personally like this. It's simple. It keeps you from messing up, or in my case, when I do something, I'm in the middle of writing a paper and I see something bad back several steps, and I'm like, oh shoot, I gotta go fix that. And I go and fix it, and then I lose my spot where I was, what I was thinking later on in the paper. So follow the waterfall model. It's a good way around that. So waterfall model has 6 phases: requirement analysis phase, system design phase, implementation phase, integration and testing phase, deployment of system phase, and the maintenance phase. Like I said, they're all in a line. You can't do one until you do the other. Then the rapid application development, or RAD. Again, the one we weren't supposed to do, but I did. So it has what, 1, 2, 3, 4, 5 phases. Not really phases, they're more like models inside the model. It's an interesting one. There's the business modeling phase, stage, data modeling, process modeling, application generation, and testing and turnover. After that, we've got the and for RAD, there's like 3, call them prototypes. Basically, you go through all of those stages 3 different times, which is nice. So it's kind of like you do it once, you go back through, you do it again, check everything. Then you go back through and you do it again and you finalize everything. You make one prototype and it's like, okay, it's not bad, it's decent. Go back through, you fix some things. All right, we're getting close to what we want. And you get to the final one and there you go, final project. So anyways, after that one's the agile model. Your favorite. I know you always told us you love agile. More I work with it, it's kind of my second favorite after waterfall. Agile model has the planning phase, requirements analysis phase, design phase, coding phase, unit testing phase, and acceptance testing phase. So agile is pretty similar to RAD, where you kind of do it 3 times. There's 3 iterations. RAD calls them prototypes. Agile calls them iterations. So you're going to go through all 6 steps, basically. 5 steps, whatever. You're going to do them all, then go up, do them all again, till you get your final project. And then the last one is the object-oriented analysis and design. So to quote a definition for that is, it's an iterative stage of analysis which takes place during the software development lifecycle that aims to model the functional requirements of the software while remaining completely independent of any potential implementation requirements. Basically, with object-oriented analysis and design, you're creating objects. Objects meaning tangible things. Excuse me, sorry. So, at least from what I took from it, it's almost like, kind of like a database. You're creating different parts of it. Can't think of the words off the top of my head. Well, here we go. The object model might describe the names, relationships, behaviors, and characteristics of each object in the system. With this information established for each object, the design process that follows is much simpler. So like I said, it's kind of like creating a database, linking it all together, making actual objects to see instead of it just being coding. So I took all of those, kind of put them all together into one. More from the spiral model, agile model, and a little bit of waterfall, and not so much from RAD or object-oriented analysis and design, because I didn't care for those as much. So basically, I made my own hybrid model. I called it the efficiency model. And like I said, put all those together. And my phases are the identification and planning phase is the first one. The requirements analysis phase. The next phase is what do I want to call this? It's a situational phase, so you don't always use it. Which is something you don't see in the other models, but I'm putting that in. Makes it interesting. So this phase is to define and organize objects, as I said, when applicable. When you're using this model for larger projects, you do this phase. When you're using this for smaller projects, which you can, you don't use this phase because it's not necessary. It's time consuming. It's just overboard. You don't need to do it. So it's interesting. After that is the risk analysis phase, then the design construction phase, and then the unit testing and analysis phase. So back to my situational phase of define and organize objects. Well, you know what? I'll get to that. Let me go through the phases. So anyways, of my 6 phases, before we get into the phases, I'll give you a little overview of my model. Basically, the efficiency model, like I said, that's what I named my model, uses an adaptive approach where there is no detailed planning and there is clarity on future tasks only in respect of what features need to be developed. There's a feature-driven development, and the team adapts to the changing product requirements dynamically. The product is tested very frequently through the release of iterations, minimizing the risk of any major failures. So, to put that into English, there's iterations, just like Spiral or Agile or Rad. There's testing that goes on the whole time, like those models. Changes can be made at any point, which is something you can't do with waterfall. And that's a big thing. That's what most models have, some don't. That's one of the biggest disadvantages, which I'll get to. So another important part is customer interaction. Again, with waterfall, there really is no customer interaction, so it's good to have that. With this model, I feel like if you were to implement it in the real world, customer interaction is important but not necessary. It's great to have. You can have the customer interaction throughout the entire process because changes can be made throughout the entire process, but you don't have to. So that's the joys of it. An interesting part here, kind of stole these words, but I like it. Like the agile model, the efficiency model, in the efficiency model, fast failure is a good thing. The approach produces ongoing release cycles, each featuring small incremental changes from the previous release. At each iteration, the product is tested. The the efficiency model helps teams identify and address small issues on projects before they evolve into more significant problems, and engage business stakeholders and get their feedback throughout the development process. There's kind of your overview of my model. I'll go into the stages a little bit here. First stage is the identification and planning phase. This phase starts with gathering and identifying the business requirements, system requirements, subsystem requirements, and unit requirements. This phase also includes understanding the system requirements by continuous communication between the customer and the system analyst. Next is the requirements analysis phase. This phase consists of a broad overview and analysis of the requirements gathered in the initial phase. A complete business analysis is performed to find the vital information for businesses, how it can be obtained, how and when the information is processed, and what are the factors driving successful flow of information. The goal of the analysis phase is to create a model of the system regardless of constraints, such as appropriate technology. The next phase is the situational specific phase. It requires it's the define and organize objects phase. It requires the creation and organization of objects. An object can be most anything in a programmatic sense. from a variable or data model to a function, class, or method. Moving even deeper into the realm of object-oriented programming, an object is an instance of a thing that typically represents a real-world object and has all the same types of characteristics, behaviors, and states. This step is a situational specific step, as it only applies to large-scale projects, as I said earlier. So you don't have to do that step. Next is risk analysis, where requirements are studied and brainstorming sessions are done to identify the potential risks. Once the risks are identified, risk mitigation strategy is planned and finalized. Next is the design construction. With inputs from the system design, the system is first developed in small programs called units, which are integrated in the next phase. Each unit is developed and tested for its functionality, which is referred to as unit testing. Simple. And lastly is the unit testing and analysis phase. The prototypes are tested through and after each step. However, the data flow and the interfaces between all the components need to be thoroughly tested with complete test coverage. Since most of the programming components have already been tested, it reduces the risk of any major issues. This step refers to the final testing and analysis while deploying the system for use. So go into, I guess, the notable advantages that I tried to focus on from all of the models that we're supposed to use. So, like I said, the ones I tried to focus on were to incorporate being able to have changing requirements changing requirements can be accommodated. Like I said, that's important. That's like the only thing I don't like about waterfall is that you can't add requirements or change requirements once you start. Like once you start, you either scrap it and start over, or you just finish what you're doing. Next is that users see the system early on. I didn't actually mean users, I meant customers. So customers can see kind of what's going on. They're going to see the prototypes because there's iterations. So like I said, you're going to produce a prototype, then another prototype, then the final project. However many times you have to go through that. Again, something you can't do with waterfall. The more I think of it, maybe waterfall shouldn't be my favorite. But next is the development can be divided into smaller parts, and the risky parts can be developed earlier, which helps in better risk management. So if you can get the risky parts done towards the beginning because you divide everything up, then you don't have to worry about getting really far along and hitting something that's not fixable or you can't get around. It's simple and easy to understand and use, which is actually something from waterfall. These steps are, the name says it all for each step. So it's not hard to follow. Phases are processed and completed one at a time. It's a very realistic approach to software development. And the phases processed, completed one at a time part. So that's where I kind of tried to throw like waterfall into with spiral and agile, because you have to do it in steps. Because like I said earlier, to me it's important to do it that way so that you don't get confused and you're not mixing stuff up. If you get to the point, even though it's a team that would generally be working on stuff, it's not a single person. You get to a point where you've got 9 different things going on at the same time, then you start confusing yourselves or your team, and you can lose track of where you're at. So if everyone just works on one part at a time, finishes it, moves to the next, it reduces that confusion and the risk of problems. It's suitable for fixed or changing requirements. Obviously, all the All the models are suitable for fixed requirements. You don't have to change requirements, but it's nice to know that you can. They're suitable. This is suitable for any size and any type of project. That's something you don't find, and that's something that has to be addressed. That's number one. With all the other models, some of them are good for small projects, some of them are good for medium to large projects. You got to have something that's good for both, or for any. So again, that's why I added the step of define and organize objects, the situational specific step. So, and lastly, frequent customer input is useful but not necessary. As I said earlier, it helps, it's allowed. You can use the input from the customer because you can change requirements or add requirements, but it's not necessary. You don't have to have input from the customer. You can take whatever they said at the beginning and work with it and finish the project. Last thing I'm going to touch on with this is the disadvantages. Some of the most notable disadvantages. Just touch on these real quick. I wanted to make sure that to eliminate the size constraints, project size constraints, which, like the last thing I said about advantages, you don't want something that can only be used for a large project or only be used for a small project. I eliminated the complex process, tried to make it simple. I didn't want a large number of stages. There's 5 to 6 stages depending, with the one stage that you don't always use. No working software is produced until late in the life cycle. That's a problem with a few of the models, mainly waterfall. I didn't like that. It's nice to see something going on early, to see what you're working towards so that the customer has something to see. Difficult to measure progress. Can't have that. Got to be able to measure where you're at, which is the sequential flow of waterfall. Cannot accommodate changing requirements. Already touched on that. You can't have that. Depends heavily on customer interaction. Can't have that. What if the customer's not around? What if they're overseas? What if they don't have time to interact with you? Customer wants something done. They don't want to be interacting the whole time, because then it's like, why are they paying you to do it if they've got to constantly be around interacting? And requires highly skilled developers and designers. Don't need that. I mean, you shouldn't have to have top level designers and everything available to be able to go over this stuff. So that is my hybrid STLC. Next, talk a little bit about, in my next 10 minutes, the final project. Final project is about the virtual robotics lab. It's interesting. It's like I said earlier on my other video. It's kind of cool to know that it's something that is a real world thing, which again is something you like to say. So throughout this semester you kept saying that, but we never really saw it. Like, you kept saying this is real world, you got to do this, it's real world. And it's like, it's really not. But for this, it is. And I like that. It's nice that you gave us a project that we can see where it's going. It's kind of like multimedia classes. You create something and you can actually see what you're creating, and you know that there's like a purpose for it, I guess you could say. So for this project, there's, we had to do the SDLC, which I just talked about, project plan component, the K combination, which luckily we had one really smart person in the class that was able to figure that out for us. And so we got the K combination, and then there's the team projects component where you divided us up into teams. For those teams, there's the project management team, which I am on with Alyssa, Greg, Jeff, Michael, and technically Chris. But as we know, he doesn't come. Then there's the social media team of Jeff, Greg, Alyssa, Ryan, Edwin, and Cameron. The security team of Scott, me, Cameron, Miranda, and Jason. Security is what I enjoy. It's what my focus is for my major. So I was excited to be on that team. It's what I wanted to do. Not great at it, but it's nice to be able to have a part in that. Then there's the web development team of Joe, Jake, Jacob, Miranda, Scott, Edwin, Ryan, Jason, and Alyssa. And then a database team of Jacob, Miranda, Scott, Joseph, Michael, and Chris. So for the security team, we've got a pretty good team put together for that. With everything you wanted. It's now Tuesday of finals week, and we've just got a couple little things to touch up on that, and we're done with the security part. Miranda was a huge help with that. Miranda did awesome. We've all contributed, done some great work with that. So to read from the file that you gave us for requirements, one part here that I've highlighted says, a security plan is needed that handles electronic and physical authentication, disaster recovery, data and information protection, physical resource protection, identity, and privacy protection, as well as a web server cybersecurity. So basically everything you would expect to have for security for an organization. I feel like we've done pretty well touching on these things. We've got security cameras in place, an overall security system through ADT. We have that, budgeted out. So that helps with the physical security, locks on everything. And then network security, you have to configure your network security, all of that stuff. Obviously, we won't technically be doing that because there's nothing to configure, but that's something you need to focus on. And one of the most important parts, something that we've all learned from Trevor Watkins in security courses, is like permissions. So, we have a section in about permissions. There's 3 levels of permissions for security, and each one basically allows you to do a little bit more. You have more permissions for different parts of the lab, more in-depth stuff. The top level, the 3rd permission level, requires that you have a secret security clearance to be able to have that permissions level, because you'll be, in contact with secret documents, stuff that the public shouldn't be seeing, and just high-tech stuff and important stuff for your project and for the robotics lab. So I thought that was something interesting to add in there, because you can't just say that all workers, just because you work for the company, should be able to view all the same stuff. And you have that with any company, so any organization at all, really. And then we had to create our UML diagrams for that. We actually haven't done those yet. We'll be doing those probably tonight or tomorrow. I know we're meeting up tomorrow, and we'll do that. That's the gist of it for the security portion. And then the project management plan. Greg is coming big on the project management plan. He's really helped out. He's really good at that. So it was nice that Greg was on this team. not just because he can do the work, but because he's good at it. He just, I guess, Greg kind of has a natural knack for it, I guess. Like I said, he did well with the project management plan. We don't have all of it done because with it, well, as it says, in addition to producing the project management plan, this team is responsible for coordinating the other teams. The project management plan must produce a 15 to 20 page document that includes a 3-page general project description and overview document, which is the NRI proposal requirements, applies to that. A detailed work breakdown structure that covers project overview document, web-based lab usage request application, virtual lab social media, user resource and lab databases, and security for the virtual lab. So basically everything, all the requirements for the entire project will go to the project management team. We will put it all together. Like I said, we've got a lot of that done, but it's not all done just because we're waiting on the papers for the other groups, so we can put it all together. But I have no doubts that that's going to be great. Everything will be put together fine. It'll be turned in, all that. I'm excited to see the final project because I think it's going to be done really well. And then we need a detailed Gantt chart for the project. Gantt charts are great. They show progress and deadlines and stuff. Really great thing to use. So, and then the project budget, we'll have that put in with the project management plan as well, which I believe most of the groups, when applicable, have put budget information. I know we did with security. We put costs for servers, cameras, the RFID cards, everything you need, for security. So I guess that's about it. Yeah, we will get all this put together. Feel like we did a pretty good job on it. Like I said, I really like the security part. It was nice to be able to do something like that since that's what I hope to do after school. We'll hopefully hear soon. So it was nice to get a kind of a first-hand look and feel for that. So I hope you enjoy the project. Hope we did it well. Yeah, hope we met all the requirements. Thank you.